Good morning, everyone. I'm Archangel, and I'll be presenting on thermal imaging. So, the theory behind thermal imaging is that everything emits infrared radiation in the form of thermal energy. So, if you see here, this is where the infrared falls on the wavelength of energy, and the human eye can only see visible light, so we're not able to see this infrared energy. Hotter objects emit IR energy at shorter wavelengths, so that'll be closer to visible light. The cooler an object is, the longer the wavelengths get. And this is the concept that thermal imaging relies on. So thermal imaging is able to pick up on those IR wavelengths and make it visible to us. So thermal cameras focus this infrared radiation onto a detector, and there's a sensor array that measures the temperature differences. There's then a signal processor that converts data into an electronic image, and it's displayed in false colors, which you can see here, and that's when colors are assigned to temperature ranges. And then cameras can be cooled or uncooled, so here you can see examples. These top two pictures are from a cooled camera, and this is taken 2 minutes after that one. As you can see, the sensitivity, it's able to pick up the temperature better than an uncooled camera after 2 minutes. So that's just something that goes into the technology of thermal cameras, but it's a lot more advanced and expensive to have a cooled camera. So types of thermal imaging. We have passive thermal imaging, which utilizes the natural infrared radiation that's emitted from objects. So, if a camera were to point at you, for example, you have heat coming off of your body, it's going to pick that up. And it can measure those temperature differences, but it won't pick up detail. So it can kind of look like just a blob of heat if it's from far away or something. Then you have active thermal imaging. This is similar to how regular night vision works. Normal night vision just has a signal amplification tube, so it'll pick up that energy and amplify it to something that you can see, but it only works if there's some light source, so like moonlight or something. You can't use it in complete darkness. Active thermal imaging allows you to use night vision in complete darkness because you have an LED, like an IR LED light or some kind of infrared floodlight. It throws out that light and it detects what's coming back in and can give you a detailed image from that. And there's no temperature difference required, so that's not going to show you heat changes across something. It'll just show you the energy that's being reflected back. So some of the applications are military and law enforcement, which you can see at the top left. That's an example of that active imaging. You can't see any heat differences really, but you can see the energy that's being bounced back by things. Engineering, it can be used for pipes to see temperature gradients in the pipes. You can see if there's any leaks or anything. Medical, this is an example of a medical use. You can see blood flow, so you're able to see clots, blood flow problems, inflammation, because inflammation is just, active blood to that site. And then environmental. So this is all burning, but you can't see that with your eye, but obviously it gives off a lot of heat, so you're able to see that with thermal imaging. So some of the advantages, it works in complete darkness, except for in that active case where you need the light. It's a non-invasive method, so you don't have to have probes, sensors, or anything inside the pipe, so you can just take a picture of it and it'll show you where the heat is. It can detect overheating, electrical issues, and leaks. It gives you instant feedback. You don't have to wait for sensors to relay information. You can immediately see what's going on. Some of the limitations, it's expensive and can be pretty complex, like I said, especially with cooled cameras. Those have lots of things inside of them. It's lower resolution than visible light cameras, so you can see extreme detail with some visible light cameras, whereas these, it'll be a few pixels across sometimes, on low resolution infrared cameras. It'll look very blocky and chunky. It just gives you rough detail. Glass can distort and block readings, so you can't detect the heat through glass just because it's going to the glass has its own heat and whatever, so it can't be seen through that. And weather and humidity can also interfere because if you have if it's foggy outside, all those rain droplets are going to interfere with those signals. So, to recap, thermal imaging transforms that invisible heat that we can't see into useful information, allows us to visualize things. It's used across many industries and can be used in life-saving situations like medical cases, military. It can be used to detect IEDs and stuff like that. This technology is rapidly evolving. There's now pretty affordable iPhone attachments you can get for $400 or $500. It plugs into your port and can be used with apps to turn your phone into a thermal camera. It's non-invasive and non-destructive, and it can be integrated with AI. So some cameras can use, like security cameras, they can pick up that radiation and track moving targets and stuff like that. Any questions?